NFA with epsilon transition to DFA direct method. Are you able to understand? Are you able to see the contents? Just inform me. I hope you are. Now I am just drawing the NFA. So this was our input NFA which we want to convert. Okay. Now using direct method, that means there is no need to convert NFA with epsilon transition to NFA without epsilon transition and then NFA to DFA. Here we can convert NFA with epsilon transition directly to DFA. Okay, so I hope you are understanding everything. Now how to convert this? So in this direct method, what we will do, we will start with a initial state which is Q0 and I am writing here or representing state not with a circle but with a capsule. Okay, and in that capsule first part is having the state name Q0. There is a second part of this capsule. What is the content of what will be the content of this first part? So the content of first part will be the single state, and with the single symbol if it is reaching multiple state part. But in this case Q0 is our initial and in the next part we will be writing the epsilon closure of Q0. So what? Q0, Q0 is already here. I am not writing here so that it will repeat it. So finally I can say that I am having a state which is Q0, Q1, Q2. So first part state name and second part epsilon closure of this state. Okay. Now since Q2 is a final state in a given epsilon NFA with epsilon transition, it is also a part of this capsule. We need to make this state as a final state. I hope this is clear. Next, what we will do, we will start. Now what is our alphabet? Our alphabet is having 0, 1 and 2. So we will check with 0 where these all states move. Okay, and its union will be considered as the corresponding state. For example, now see here Q0 on 0 moves to Q0, right? Then we have to check it for second part also. Q1 on 0 moves anywhere? No. Q2 on 0 moves anywhere? No. So finally with whole consideration Q0, Q1, Q2 on 0 moves to only Q0. So the state name is Q0, that's why I have written here self loop. So I hope this is clear. Now again we have to check this state with the second input symbol. So second input symbol is 1. So here what it will be? Q0 on 1 moves where? So Q0 on 1 moves nowhere. Q1 on 1 moves to Q1 and Q2 on 1 moves nowhere. That means this state on 1 moves to a state named as Q1. Right? Now again we have got a new state Q1. So having epsilon closure. So epsilon closure of Q1 is Q1, Q2. Q1 is there. So I am writing Q2. Okay. Now since Q is involved, I need to make this state as final state. Clear? Now we have to consider this 0 state on there. On 2 goes there. Q1 on 2 goes nowhere. Q2 goes to Q2. So this is again a new state. So to one state which is named as Q2. I am making circle because it is that closure. We don't make here it it's okay. So Q2, this state on 2 moves to Q2. Okay. So turn of this state is over. Now we have received these two states. So we need to consider it for Q1 and Q2 as well. So here Q1 on 0. We have to consider for each every input symbol. So Q1 on 0 moves anywhere? No. Then Q2 on 0 moves anywhere? No. So there will be no transition for this state with 0. Now there is a turn of 1. So Q1 on 1 moves to itself and Q2 on 1 moves nowhere. So the union of Q1 and nowhere, that is why it's Q1. So we can have here Q1 itself, right? Next, there is a turn of 2 for checking with Q1. So Q1 on 2 moves anywhere? No. Q1 on 2 moves anywhere? No. Then Q2. Q2 on 2 moves anywhere? No. Sorry. Q1 on 2 moves anywhere? No. Q2 on 2 moves to itself. That means to a state. So I need to have the transition as this. Is it clear? Q1 on 2 goes there. Q2 on 2 goes to Q2. That's why this transition is there. So the turn of this state, that is Q1 state for all input symbols 0, 1, 2 is over. Now there is a turn of Q2. Now Q2 on 0 moves nowhere. Q2 on 1 moves nowhere. But Q2 on 2 itself. So there will be a self loop with 2. So this will be my final DFA. Okay. So if we that, so it nothing but Q1 and Q2 state 0. So can we compare this diagram? Is it giving same as we have designed? Now we can compare. Are you able to see? Now these are our two DFAs. So this is with the direct method, this is indirect method. Now verify. So there is a state Q0, there is a Q0. Q0 on moves to itself. Here also Q0 on 0 moves to itself. Q0 on Q1. Here also Q0 on 1 moves to Q1. Right? Then here Q0 moves to Q2. See here also Q0 on 2 moves to Q2. Is it? Same way, if we will observe Q1, so Q1 on to itself and on 1 moves to Q2. Similarly, Q1 moves to itself and 2 moves to Q2. Next, there is a turn of the Q2 on 2 moves to itself transition. Similarly, also you can see Q2 is itself, there is no more transition. Okay. That video I have explained how to verify this. Okay, the is having we have 0, 1, 0, 0, 1, 0, 2. These are accepted by this DFA. So if you will it, you Q0, Q1, Q2 or ABC, anything, the diagram will be same. Is it acceptable? So just check. 0 is acceptable to this GFA. So there is a final state. So on 0 it is remaining into Q0, which is a final state. So acceptable. Only one is acceptable. Yes, Q0 on Q1 state, which is a final state. 0, 0, so 0, 0 with 1 moving to this state, which is final. Next 0, so 0, 1 and final state. Let me, if I am having inputs 0 to 1, acceptable to the equivalent DFA, we need to take. Now let us, so 0, it will be with moving here. Next is 2. So with moving to this Q, right? And then there is to 1. Is any transition there? No transition. So since you have not read this string completely and not reaching final state, particular is not a of language which is acceptable by this DFA. Okay, so this is a direct method of NFA with to conversion. So just to this type of this here. So if M1 was for say M1 for NFA with epsilon transition, then M2 for NFA without epsilon transition, then we can say that we have just created the M machine which is equivalent to which is the DFA. So if I want to represent this M3, how I will represent? It will be M3, what it is equal to Q summation delta 2 dash, we can say 0 F2 dash. So what Q are 3 state final one. So actually it could have 2 bar Q. We know the change from NFA to DFA conversion. Will Q will change in DFA? Yes, it will change. It right. Epsilon will be delta dash Q0 and dash. So Q will bring how many possible? So Q0, Q, Q, then combinations. So there will be 2 raised to the power 8, right? As Q 2 dash and your delta 2 dash, your DFA. What about F? F is nothing but whatever. So original NFA with epsilon move, you had one state, right? Equivalent DFA dash, you had how many final states? So we can say all the combinations which are so it was 0, 1, Q2, then Q0, oh sorry, and Q1 and Q. All these are finals. Okay, so in this way, so you will get in the paper, you will be given one NFA with epsilon move and you will be asked to convert that into either NFA without epsilon transition or to convert NFA with epsilon transition to DFA. So according to the marks and time you have your you have to proper method the NFA with a transition to machine. I hope you understood all this.